Folks, we have a definite integral comprised of the product of a ceiling function and a fractional part function. These are two functions, and let's talk about what those functions do. Let's make up an example that's related to this interval. Let's say we wanted to do the ceiling of, let's say, just something easy to do here, 22 over 7, which is a number in this between these two limits of integration. Let's do 22 over 7, yeah. 22 divided by 7. Okay, now intuitively, the ceiling of this is the next highest integer. So this is equal to, this is actually going to be 22 over 7 is between 3 and 4. So the ceiling of 22 over 7 is 4. Okay, and you see that fits this definition of 4 minus 1 less than 22 over 7. Is less than or equal to 4. Because the ceiling or the floor of any integer is just the integer. Okay? So that's an example of the ceiling function. And the fractional part function is very, very natural too. Let's do the same thing. We'll try the fractional part. And y'all, they could just as easily call this the proper fractional part. Okay, so 22, proper fraction is a number strictly between 0 and 1. So let's do this one, 22 over 7. Okay, so again, intuitively, you'd expect this to be 1/7, but notice that's consistent with this definition. 22 over 7 minus the floor, not the ceiling. So 22 over 7 minus the floor of 22 over 7 is 22 over 7 minus 3, but that's equal to 1/7, okay? So again, formal way to do something that's very straightforward. You can just do these things in a flash, in your head, okay? So let's take a look at this integral now that we know the meaning of these two functions. Okay, so here's our integral just recopied, and the numbers in this interval are between 3 and 4. That means the ceiling is 4, just like our example up here, okay? So again, all the values in this between these limits of integration are between 3 and 4. Right, between 3 and 4, so that makes the ceiling 4, and it also makes the fractional part x minus 3, just like this problem right up here. Okay. Now again, the rest of this is just integration. You can take the constant outside of the integration because the integration is just a infinite summation, and it's just a distributive property. Okay. So what will this end up giving us? That would be 4 times the antiderivative of x minus 3 quantity squared, right? So that's 4 times x minus 3 quantity squared. And by the chain rule, basically, you're not just over 2. This is the antiderivative, right? This is the antiderivative. And I should be putting the little bars here. This is the convention, I think, in calculus. You do this, and you put the upper limit of the integration up here. Okay, and that means this is a work in progress. You intend to substitute these values in here and subtract. Okay, so what do we get here, folks? Now, 4 over 2 is just 2, right? So we can write down this 2 times. Now, y'all, I'm going to go ahead and just do it here because when you notice that when you substitute 3 in here, you get 0. Okay, and when you substitute 25 over 7 in here, you get 4 over 7. Okay, but you have to square that, right? And so 4 over 7, let me just write it down, okay? So this would be 4 over 7, right? Quantity squared. All right, and that's just the same thing. This is 16 over 49. 2 times 16 is 32. So the answer is 32 over 49, and these are square units, right, folks? I'll leave that out, but that, the area interpretation. And this is just a little triangle. If you draw a picture of this, you'll see it's just a triangle multiplied by 4, one of the sides there, But anyway, that's the answer. 32 over 49, folks. Hope you enjoyed that one.